Welcome to True Projects. In this video, we are going to explain about a project titled A Vision-Based System Design and Implementation for Accident Detection and Analysis via Traffic Surveillance Video. So now coming to the introduction part. In the domain of traffic control and safety, the swift identification of accidents are of utmost significance. This is crucial for reducing response times and obtaining valuable insights into road safety. This pioneering method harnesses the capabilities of the computer vision and artificial intelligence to elevate accident detection, providing a valuable instrument for traffic management and accident analysis. To cater to this critical requirement, our study introduces a vision-driven system crafted for the purpose of recognizing and scrutinizing traffic accidents using surveillance video data. So now coming to the objective part for this project. The goals of the study titled the design and implementation of a vision-based system for accident detection and analysis using traffic surveillance video are guided by some main intentions. The first here we have instantaneous accident identification. The foremost goal is to create a simple capable of promptly identifying accidents in real time via traffic surveillance video. Second here we have precision in categorization. The research strives for precise categorization of the recognized accidents. Its objective is to differentiate between various types of accidents, offering valuable insights into the severity and characteristics of each accident. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and Seaborn for visualization are important. Second, here we have exploring the dataset accident detection data. This step involves examining the dataset related to accident detection to understand its content, structure, and characteristics. It's crucial for data preparation and model building. Then next here we have installing the packages required for YOLO V5 in Colab. In a Colab environment, this step involves installing the necessary packages, dependencies, and libraries specially required for YOLO V5, which is a deep learning model for object detection. Next, we have processing the data based on the YOLO V5 model. Data pre-processing tasks are performed to prepare the data for use with the YOLO V5 model. This may include tasks such as resizing images, label encoding, and data augmentation. Then next here we have building the model in Colab. The YOLO V5 model is constructed and configured for license plate detection. This involves setting up the architecture parameters and layers necessarily for the model to perform the object detection. Then we have training the model. The YOLO V5 model is trained on the prepared dataset to learn and recognize license plates in images or video. Next we have building the model with YOLO V5. This step might be a repetition of step 5 for a separate model configuration. Ensure that the YOLO V5 model is ready for license plate detection. Flask framework with SQLite for sign up and sign in. The Flask web framework is integrated with an SQLite database for user registration and authentication, typically used to create a web interface for users to access the license plate detection service securely. The next step we have user gives input as image or video. User provides input in the form of images or video that they want to analyze for the license plate. Then we have the given input pre-processed and with the trained model is used for detecting the license plate. The user provides images or video undergo pre-processing to ensure that they are in the correct format and scaled appropriately. Then the trained YOLO V5 model is applied to identify and locate license plate. Next here we have the segmented each object input bounding box. After detection, the identified license plates and other objects are enclosed in bounding boxes for visualization and presentation. And the last one here we have final outcome is displayed. The results including detected license plates and their bounding boxes are presented to the users through the front end, enabling the users to view and work with the detected objects. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Then we have another folder which is named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Next here we have .ipy file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Next here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the class framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here and now hit the enter button. So here you can see that this is our home page for the vision-based system design and implementation for accident detection and analysis via traffic surveillance video. These are the features which are providing YOLO v3 accident detection and YOLO v5. There's a button for sign up. Just click on this button and enter your username, name, email ID, phone number and your password over here for doing registration. I have already done the registration, so I am clicking on sign in button. Just enter the username and the password over here which you have created while doing the registration and simply click on sign in button. So by scrolling down below here you can see that it is asking for uploading any of the image. Just click on the choose file button and let me choose the image from this. So here you can see that there are many different images. Suppose that I am clicking this image and now click on open button. Click on upload. So here you can see that it is detecting as severe accident and severe accident. So depending upon the image you're uploading over there, it will detect about this. Here you can see that there is a button for about. Just click on this button. By scrolling down below, here you can see these are the features which are providing YOLO v3 accident detection and YOLO v5. Just click on YOLO v5 button and it is asking for uploading the image. So here let's try with uploading another images. So suppose here I am clicking on. Okay, let me open the folder for uploading the image. So here you can see that we have to choose any one of the image from these images for the accident detection. Suppose that I am choosing this image first over here and now simply click on open button and let's click on again upload button. So here you can see that it is detecting as a moderate accident 0.74, moderate accident is 0.63. Here you can see that the two cars are colliding with each other and the accident is happened over here. So depending upon the image you're providing over there, it will detect the accident whether it is moderate or not. Here you can see that there is a button for sign out. By simply clicking on this button, you can successfully log out with this. So now coming back to the conclusion part. To sum up the study and execution of the vision-based system for accident detection and analysis using traffic surveillance video have produced a hopeful and pioneering answer to the pressing issues in traffic safety and administration. By leveraging the potential of computer vision and deep learning, the system offers a real-time, precise and data-centric method for identifying and analyzing accidents. It brings numerous advantages to the realms of road safety and traffic management. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.